Hello, welcome to today's exciting lesson in our Chemistry Explained series, part 7. Today we're looking at the electronic configuration and the periodic table. In part 6 of our series, we looked at the structure of the atom. You need to watch that video to see the details of the atomic structure. Electronic configuration we're looking at today is important in understanding the periodic table. We need to look at the energy levels or subshells or orbitals to understand electronic configuration. From Bohr's model of an atom, as you can see there, you can see that electrons are arranged in different energy levels. Number 1, number 2, number 3, on and on and on. What are the subshells and how do electrons fill them? There are 4 subshells, namely sharp, principal, diffuse, and fundamental, known simply as S, P, D, F. These terms were based on how spectral lines appeared in early experiments in spectroscopy. Do not bother about that yet. The s orbital, the first one, has 1 sub-level and it can accommodate a maximum of 2 electrons with opposite spin. The next one is the p orbital. It has 3 sub-levels. It can accommodate a maximum of 6 electrons. We have the next one, d orbital, with 5 sub-levels. It can accommodate a maximum of 10 electrons. Then lastly, we have the f orbital with 7 sub-levels. It can accommodate a maximum of 14 electrons. How do electrons fill up this orbital? Very important question. There are 3 fundamental principles that apply in filling the electronic configuration. Number 1 is the Abel principle. Number 2 is the Horn's principle or Horn's rule. Number 3 is the Pauli exclusion principle. What is Abel principle? It says that electrons fill the lowest energy orbitals first before occupying higher energy levels. Bear that in mind. Number 2, Horn's principle, Horn's rule. It states that electrons occupy orbitals singly and with the same spin before they form doubles with opposite spins. Number 3, Pauli exclusion principle states that no 2 electrons in an atom can have the same set of quantum numbers. How do we write electronic configuration using this principle? The Abel principle. Look at the diagram of the Abel principle. You see the numbers are arranged 1, 2, 3, 4, 5, 6, 7. Can go beyond that, but stop there. Then you step down. You start with it again 2, 3, 4, 5, 6, 7. You go to the right again, you step down 3, 4, 5, 6. You go to the right again, you step down 4, 5. So by the time you see that, then you cross an arrow from up diagonally, you strike it down, arrow pointing down. So you have 1s, you have 2s, you have 2p, 3s, 3p, 4s, 3d, 4p, 4s. So when they arrange in a straight form, you see 1s comes before 2s, 2s comes before 2p, after 2p you have 3s, after that you have 3p, after that you have 4s, after 4s you have 3d, on and on until you get to 4f. These areas, the elements 103 that we have can be accommodated there. Over 100 elements, they can be accommodated there. The diagonal rule determines the filling order. Each subshell has a specific energy level, and the diagonal rule helps in remembering the order electrons fill the orbitals in the following sequence: 1, 1s, 2, 2s, 3, 2p, then 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s. Just as illustrated, you go up, you come down, you go up, you come down. All this with correct order. The diagonal rule is important. Why? Because it predicts electrons' configuration easily. Number 2, it explains periodic table structure. In the periodic table, you have the S group, you have the P group, you have the D group, you have the F group, F blocks. In number 3, it helps us to understand the properties of elements and their chemical behaviors. Then examples of electronic configuration. Look at hydrogen, element number 1 in the periodic table. The electronic configuration is 1s1. That one is superscript that shows the number of electrons. Helium, 1s2, 2 electrons. Oxygen, element number 8, you see 1s2, 2s2, 2p4. Look at the superscript, 2 plus 2 plus 4, 8, the number of electrons in oxygen. Magnesium, element number 12, 1s2, 2s2, 2p6, 3s2, maximum of 12 electrons. Iron, the element in transition series, with a total number of electrons 26. You see the filling 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. And these are the way they are arranged in their configuration. Another important thing we need to know in this is what we call periods and groups. In the periodic table, elements are arranged in periods and in groups. Elements in the same period have the same number of shells. For example, period 1, you have 2 elements there, hydrogen and helium. They just have 1 shell. In period 2, they have 2 shells, starting from lithium. You go on and on until you get to neon. Period 3, you start from sodium, you go on until you get to argon. So this number of the shells determine the period. But when we talk about group, elements in the same group have the same number of valence electrons. Elements in group 1 contain elements that have 1 electron in their valence shell. The valence shell means the outermost shell, and these valence electrons determine chemical properties because the electrons that are involved in reaction are located in the valence shell. In the same periodic table also, we have blocks of the elements. We have S block elements comprising of group 1 and 2, the alkali and alkali earth metals. Their valence electrons are in the S orbital. Then the P block elements, they occupy groups on the right in the table of periodic table comprising of metalloids. That's the non-metals also, like halogens, the noble gases. And their valence electrons are in the p orbital. We have D block elements, popularly known as transition elements. The electrons fill up in the d orbital. We have the F block elements, popularly known as the inner transition, the lanthanides and actinides. The electrons fill in the f orbital. Today we have learned on the electronic configuration and the periodic table. The electronic configuration rules that apply are the Abel principle, the Horn's principle, the Pauli principle. Periodic table has a direct connection to the electronic arrangements. Please practice writing electronic configuration for as many elements as are possible. Subscribe and hit the notification button for more exciting videos. Thank you.